Good morning. We're just going to have a look at this paper. I'm going to give it a quick run through and see what it is. It's Double Award Physics. It's Unit 1. It's hired here. It's Wednesday, the 13th of November 2024. So we'll start off here. The first one, some concrete pavement slabs are shown below. The concrete has a density of 2,400 kilograms per cubic meter, so that's grand. The volume is 0.02 meters cubed, that's grand. So I'll show you working out here to get 3 marks. Units given, density equals mass over volume. We've been here before with the old keep it simple, stupid. So density equals mass over volume, mass equals density times volume. Nice opening question, that. No tricks, no nothing, just plain and simple. Metal rods are made by pouring hot liquid metals into a mold and allowing it to cool and become a solid metal. So what is this? Well, we know that liquids are less dense than solids. So this one here, less dense things float on top of more dense things. So gases float on top of liquids and liquids float on top of solids. So the air or the gas is least dense and the solid is the most dense. The plane flies in a straight line at a constant height. Now if it's a constant height, just look at the force diagram here. Nearly a technical drawing there. If it's a constant height, the uplift is equal to the weight. It's balanced in the vertical plane. The plane accelerates forward, so it's not balanced in the horizontal plane. So this force is greater than the drag. This force is greater than the drag. The uplift is equal to the weight. So the force is greater than the backward force. The forward force, now remember force is a vector, it's got magnitude and direction. Magnitude is the fancy name for size. If the forward force acting on the plane is positive, how would the backward force be described? Well, if that way is positive, then that way is negative. What is the name of the backward force that opposes the motion of the plane? Air resistance. Fair enough. I haven't done my homework right. Just make sure. Yep. Friction, air resistance, drag. I've used those terms anyway. So that's that question done. Again, you should have this printed off. You should have the mark scheme printed off. And you should be going through it, trying to get all the marks. So the plane remains at a constant height. How do the upward and downward forces compare? Talked about this here earlier. The uplift is equal to the weight because constant height, so the force is balanced. Just adjust this ever so slightly. The weight of the plane is 7570 newtons. Calculate the mass of the plane, W equals mg. Another equation for you to learn. Newtons, kilos, 10 meters per second squared if you're on the earth. There's the rearranging, W equals mg, 757 kilos. The units there for you. Look at the mark scheme. Did you get all 3 marks? Did you miss any? Next question. A helicopter is used to lift a load. So again, W equals mg. Force up is equal, right? The helicopter has a mass of that, so there's the weight of the helicopter. And the load has a mass of that, so that's the weight of the load. The mass is 470, the weight, the force is 4,700. The helicopter and load accelerate vertically upwards at 7 meters per second. Calculate the resultant force acting on the combined helicopter and load. This is Newton's second law, dear old Isaac. The resultant force is equal to mass by acceleration. So resultant force, the mass, don't forget, is kilos. Didn't write that down. Kilos. Meters per second squared. Resultant force, so resultant force is the mass, add the two together, so the resultant force up is 7910 newtons. 4 marks for that one. Some nuclei are radioactive and emit radiation. 3 types. Here's a box. Alpha. There's the symbol. There's the other symbol. There's 2 protons and 2 neutrons. It's a helium nucleus. There are no electrons in it. Beta particle, fast moving electron from the nucleus, always causes confusion. The neutron splits to give you a proton and an electron. Gamma ray, pure electromagnetic radiation. So you fill them in. What are we looking? 3 types of radiation, and describe what each consists of. 3 types of radiation, alpha, beta, gamma, and there's what they consist of. You learn that. I can't learn it for you. Radioactive decay can be described in terms of half-life. Explain the meaning of the term half-life. Go to the mark scheme. You need to know this. Have a look. We're looking 2 marks. The time taken for the activity or mass or number of undecayed nuclei to have. You know it. No, you don't. A radioactive isotope thorium is known to have an activity of 3,200 becquerel. When the radioactive isotope is brought into the laboratory, the total activity is measured at 3,218. Now, this extra 18 is the background radiation. Background radiation is from outer space, it's from nuclear accidents, it's from rocks in the earth, it's from medical procedures. That's where the background radiation comes from. So the background's 18, and the reading is that, see? Source plus background is equal to the real reading. So always be careful of the background. A sample of uranium-229 is a mass of 0.8 grams. After 174 minutes, the mass of the sample is found to have decreased to 0.1. Now, this is a slightly different one in the mass. Remember, the mass doesn't disappear. It changes into another type of nuclei. So 0.8, 0.4, 0.2, 0.1. Half-life. No half-lives. 1, 2, 3 half-lives. And 3 half-lives, it tells you, is 174 minutes. So 1 half-life is 58. Do the table and work it out. Next question. Again, it's a velocity time graph. How do I know? There it tells you. Look, exactly. So, calculation's not required. It's decelerating. It's stopped. It's accelerating. And then it's going at a constant speed. So, that's it. Decelerating. Stopped. How do I know it's stopped? Velocity 0. Accelerating. The speed's increasing. How do I know? Well, it was 10 there. It was not there. And then finally, it's going at a constant speed of 10 meters per second. So calculate the total displacement of the car during 0 to 30. Now just have a look at that. These always give a nasty twist. You be very careful of the time they're asking. It says 0 to 30. You don't find that area there. So again, if you look at my method, sorry about the jigging about today, but it's just one of those days. It's that area plus that area. So you're working out 2 areas. Half base by perpendicular height, half base by perpendicular height. Add them. Unit. So I would have got 4 marks for that. Check the mark scheme. Let's have a look at the mark scheme. Displacement equals area under a graph. Then there's your calculations. There's your 4 marks. So if you just write down the answer, you're not getting all your marks. Now, a box is raised vertically to a height of 1.4. They're measuring from the base here. Always be careful. The examiners are sly in where they're measuring the distance from. So that's greater than 1.4. The box has 360 joules at X. So that's 36 joules there. The box has a mass of 2 kilos. Now, here comes the slyness. Calculate the increase in height. So we find the new height and you want the increase, so it's the difference. So this new height is 1.8. There's the calculation. Look, P equals mgh. Should have that in a bracket. Right? M by G by H is 36. And it's an X. So the height is 1.8. And here comes the rogue steer. And I tell you, keep reading these things. These things, it's the increase in height. So it's the difference. Look, 1.8 take away 1.4. 0.4. Slippy at the end. Always read the question carefully. Another box is rated vertically. The box has a weight of 1.7 newtons. Calculate the work done. Work done equals force by distance. Newtons, meters, joules after dear old James Prescott. Look, 340 centimeters. I need the meters. Distance in meters. Look, I need meters. Work done, same as energy. Force by distance. Now look, here's another twist in the tail. Whole number. Works out at 5.78. The nearest whole number is 6. So that there question has plenty in it to dupe you. Back to our old favourites. Cross zebra. That's the number of protons. It's also known as the atomic number. That's the number of nucleons. Nucleons are protons and neutrons found in the nucleus, collective noun. That's atomic mass. What does the letter A represent? Atomic mass number. What does A? Atomic number. If you don't learn that, you don't know it. Now, the nucleus. Remember, the nucleus doesn't have any electrons in it. Yet they're going to ask you down here. This question's come up before. So it's got 18 protons, there's 22 neutrons, and no electrons. You see the way the slippy examiner has said nucleus? They didn't say a neutral atom. So be careful on that one. Be aware of the question that is being asked. Right? We've talked about this before in many other videos. We talked about the bog standard carbon-12 and the fancy carbon-12. Both have 6 protons. This is 12 nucleons, 6 protons, 6 neutrons. This is 14 nucleons, 6 protons and 8 neutrons. Fair enough? There's the answer. Isotope, something for you to write down and learn. Same number of protons, look, there's it there. Same number of protons, different number of nucleons, different number of neutrons. So we've horsed through this one quite well. Nuclear energy. There's the equation. I'd say keep learning it. Uranium collects a slow neutron, splits to tellurium and zirconium. 2 neutrons are created. We use these for a chain reaction, and then we use the energy to heat water for a turbine to turn a generator to make electricity. That's a nuclear power station, a controlled reaction. Uranium or plutonium will do, and it's non-renewable. When you use uranium, that's it, spent, gone, can't use it again. For nuclear fission to occur, the nucleus, look, there's it there. For nuclear fission, a nucleus must absorb a particle. That's why I say learn it, and it's a slow-moving neutron. Nuclear fission releases energy. Name 2 other things produced, look. Smaller nuclei and neutrons, all coming from this. A single fission can go on to cause further fissions, and this is known as your chain reaction. Remember the Diana Ross video showed you. The reason for that is to remember a chain reaction. Diana did a bit of singing in her day. What's the major environmental disadvantage? The radioactive waste. And fusion. reacts and produces 100 units. Well, this is 25. I didn't know that either. So, you know, you read the question, you read the mark scheme, and you learn it. We're on to the last question. Explain fully what is meant by the centre of gravity. So it's a point where all the weight appears to act. Learn it. A box is placed on a uniform meter rule. So the meter rule, that's 50. Uniform means the centre of gravity is in the middle. So it's balanced. So let's have a look. It's balanced. That force there turns it anti-clockwise. That force there turns it clockwise. What did I always tell you about these sort of questions? Be aware that the examiner is going to make a twist on the distances. 50. That's the centre. 6 and 4 and 24 is 30. So that must be 20. The moment is the force by the distance from the pivot. Look, there's the force. There's the distance from the pivot. I'm taking moments about this pivot. And that makes it move anti-clockwise. Next one, force. There's the force by the distance from the pivot. 24. Fair enough. State inwards the principle of moments and include the unit. If a body is in equilibrium, that's 1 mark. The sum of the anti-clockwise moments is equal to the sum of the clockwise moments, 2 marks. About a point, 3rd mark. Units, Newton meters. You check the mark scheme to see whether they take Newton centimeters. Look, a moment is force by distance. Not really good enough, that. I should have put the word perpendicular in there. So go and do the question then. The sum of the anti-clockwise moments is equal to the sum of the clockwise moments. 2 by 24. W, force by 20. Again, if you can't rearrange formula, there's a keep it simple. So the answer becomes into 2.4. Again, there's my 3 marks I was looking up here. Clockwise moments is equal to anti-clockwise moments if in equilibrium, about a point. So that was a wee bit quicker than normal. Thanks very much if you watched it.